In this video, we're going to be talking about adding and subtracting square roots. So up to this point, we've been simplifying radical expressions, and now we're going to simplify some more complicated ones that involve addition and subtraction. So let's go ahead and get started. So here we have the square root of 32 minus 4 times the square root of 98. So the goal here, and with each of these, by the way, is that we're going to try and get the same expression underneath the radical after we simplify everything, okay? So the first thought I have here is to see if we can simplify each of these. So maybe we have a square root of 2. That might be a good thing to do. So if we have the square root of 32, that can be written as the square root of 16 times 2. Then we have minus 4 times, looks like we have 49 times 2. Yeah, that looks good. That looks like it's going to work, okay? So let's see how this is all going to play out, okay? So here we can separate our square roots now. We have the square root of 16 times the square root of 2 minus 4 times the square root of 49 times the square root of 2. Okay, this is looking good. So now we have the square root of 16. That's 4 times the square root of 2 minus 4 times 7 times the square root of 2. The square root of 49 is 7. Okay, so we have... looks like we have 4 times the square root of 2 minus 7 times 4 is 28 times the square root of 2. And now we can factor out a square root of 2. So we have this, we can do 4 minus 28 times the square root of 2. And 4 minus 28 is going to give us negative 24 times the square root of 2. Okay. Move everything down. Okay, here we have negative 75 minus 3 times the square root of 27. Okay, so I noticed that each of these are divisible by 3, so maybe that'll be a goal. So if we divide 75 by 3, we'll get 25 times 3. That's good. We want that. So negative the square root of 25 times 3 minus 3 times the square root of 9 times 3. That's good. Okay, so we notice that 25 and 9 are both perfect squares, so that works out really well. Okay, so we have negative the square root of 25 times the square root of 3 minus 3 times the square root of 9 times the square root of 3, which is going to give us negative 5 times the square root of 3 times 3 times 3 times the square root of 3, which is going to give us negative 5 times the square root of 3 minus 9 times the square root of 3. And if we factor out that square root of 3, we get negative 5 minus 9 times the square root of 3, which gives us negative 14 times the square root of 3. Okay, how about negative the square root of 98 minus 5 times the square root of 50? Okay, so I'm thinking 2 again, because we know that if we divide 98 by 2 from a previous problem, we'll get 49 times 2. That's good. And then if we do 50, we'll get 25 times 2, which is also good. So we'll have negative square root of 98, no, not 98, sorry, 49 times 2 minus 5 times the square root of 25 times 2. Let's give us some more space here. Okay, so if we split everything up, we'll get negative the square root of 49 times the square root of 2 minus 5 times the square root of 25 times the square root of 2, which is going to give us negative 7 times the square root of 2 minus 5 times the square root of 2, which is going to be equal to negative 7 times the square root of 2 minus 25 times the square root of 2, which is going to give us, after we factor everything out, we'll get negative 7 minus 25 times the square root of 2, which is negative 32 times the square root of 2. Okay. How about negative the square root of 20 minus or plus 5 times the square root of 45? Okay, so what I'm thinking here is we could do, let's see, probably 9 and 4 would be our two that we're looking for here. So we could do, we could have negative the square root of, so 20 we could divide up as 5 times 4, okay, plus 5 times the square root of 9 times 5. That should work. So we're going to have a perfect square with 4 and a perfect square with 9. That's what we're looking for. So we get negative the square root of 4 times the square root of 5 plus 5 times the square root of 9 times the square root of 5. And we'll get negative 2 square root 5 plus 5 times 3 square root 5, which is going to give us negative 2 square root 5 plus 15 square root 5, or we have negative 2 plus 15 square root 5, which is positive 13 square root 5. Okay, not too bad. Now things get a little more complicated. Here we have 7y times the square root of 72y plus 50y plus the square root of 50 times y to the third. Okay, so here we want to see what we can simplify. Okay, so I'm guessing we're going to want to keep a y underneath here. That's fine. But 72 we could divide by, perfect. If we divide 72 by 2, that'll give us 36 times 2, so we'll have a perfect square of 36. And then 50 we could do 25 times 2. So let's rewrite this whole thing as 7y times the square root of 36 times 2 times y plus the square root of 25 times 2 times. Now we're gonna do the same technique we did last time here. We're gonna do y squared and then y. Okay, and the reason for that is we're gonna try to see if we can pull out a y squared here. Okay, so we have 7y times the square root of 36 times the square root of 2y plus the square root of 25 times square root of y squared times the square root of 2y. So now we have the two y's in common. So that's our goal, is to try to find something that we can latch onto in each of these, right? So now let's simplify a little bit. We have 7y times 6 times the square root of 2y plus 5, and the square root of y squared is just y, 5y times the square root of 2y. Perfect. Okay, now we have 7 and 6, so we have 42. So we have 42y times the square root of 2y plus 5y times the square root of 2y. And now we can factor out that square root of 2y. So we have 42y plus 5y times the square root of 2y. So we're going to have 47y times the square root of 2y. Beautiful. Now these might look really complicated, and admittedly, there's a lot of intuition that goes into this. But the more you do this, the easier this will become. So I would just really encourage you to go on to ALEKS and spend as much time doing these as you can. We'll do a few more of these just so we can get some experience with them. But I would just really encourage you to go on to ALEKS and spend as much time on these as you possibly can, because that's how you're going to get good at them. Okay, here we have 19z to the 8th times the square root of z minus 3 times z, the square root of z to the 17th. Okay? So I'm guessing because this is written as the square root of z, that's probably kind of our anchor point, if you will, the thing we're looking for here. Okay, so let's see if we can rewrite z to the 17th so that we can get a square root of z out of that. And we can. So we can rewrite this as 19z to the 8th times the square root of z minus 3 times the square root of z to the 16th times z to the 1, right? So that'll be 16 plus 1, or just times the square root of z. So this becomes 19 z to the 8th square root of z minus 3 times z, the square root of z to the 16th times the square root of z. So now we have that square root of z in common here. And now we can just simplify. Okay, so the square root of z to the 16th, remember we can rewrite the square root of z to the 16th is equal to z to the 16th raised to the 1/2. So we multiply 16 times 1/2 gives us 8. So this becomes z to the 8th. So we have 19 z to the 8th minus 3 z to the 8th. I'm sorry. We have the square root of z over here. Square root of z minus 3 z to the 8th times the square root of z. Okay, if we factor out that square root of z, we get 19 z to the 8th minus 3 z to the 8th times the square root of z. Okay, so if we subtract those, we're going to end up with 16 z to the 8th square root of z. And that would be your final answer. Okay, let's do a couple more. Here we have 3y times the square root of 80 times y to the 3rd minus the square root of 20y to the 5th. Okay, let's see what we can do. I think we could probably get a... Can we pull out a square? It looks like we can pull out maybe a y squared from this right side here. So this will become 3y times, I guess we could do, for the 80 part, we could do 80, we could do, let's see, what can we do here with this? 80, well, we'll just do this one step at a time, so we can probably do a little better than this. But we will do 80 we can write as 20 times 4. Or how about 9? Can we do 9? No, that's not even divisible. What am I even saying? I don't even know what I'm saying here. I'm not making any sense. See, it's okay to make mistakes, and it's okay to sometimes have to think about a problem for a minute before you get somewhere with it. But we can write this as y to the 3rd. And then we can have minus the square root of 20 y to the 3 times y squared. Okay? And the thought there is that we should be able to pull out that y squared pretty easily. So we have 3y times 20 times 4 times y to the 3rd. Okay? Minus the square root of 20 y to the 3rd times the square root of y squared. Okay? Okay, so we can pull out that 4 too. So we have 3y times the square root of 20y to the 3rd minus, so the square root of y, I'm sorry. Then we have the square root of times the square root of 4 minus the square root of y squared is just y times the square root of 20 y to the 3rd. Okay, so this becomes 3, well, the square root of 4 is just 2, so we have 3 times 2, so that's 6y times 20, square root of 20y to the 3rd minus y times the square root of 20y to the 3rd. Okay, and I bet we can still do better than this, right? So we can pull out a, we can divvy this up. So we have, if we factor out this 20y, square root of 20y to the 3rd, we will have 6y minus y times the square root of 20 y to the third, which is going to give us 5y times the square root of 20 y to the third. And we can actually still do a little better than this, right? So we can factor out we can rewrite this. So we can write 5y times the square root of 5 times 4 times y squared times y. Okay, so that's going to give us 5y times the square root of 4 times the square root of 5 times the square root of y squared times the square root of y. So we'll have 5y times 2 times the square root of 5y. We'll combine those two back together, 5 and y, right? And then we'll have the square root of y squared, which is just y. So we have, this one became kind of a mess, right? So here we have 5y times 2 times the square root of 5y times y. Okay, so let's combine everything that's outside the radical. So we have 5 and 2, that's 10. We have y and y, that's y squared. And then we have times the square root of 5y. So looks like our answer is 10y squared times the square root of 5y. That was a mess. So sometimes these can be pretty nasty, but it's just kind of working through it. And obviously, I think with this one, maybe not obviously, but with this one, I think that we probably could have simplified a little better in the very beginning, but it's okay to simplify later too. Maybe you didn't simplify it as well as you wanted in the beginning, but you realize, you got halfway through, like I just did, and realized, oh, we could have done better. That happens. So that's totally fine. Okay, let's try. Let's see. This one looks a little similar to the last one. We'll do it anyways. Good practice. So here we have 20z to the third, square root of 20z to the third plus 3z times 80z. Okay. So let's see what we can do here. So we can rewrite this. I think I figured out the mistake I made last time. We can correct it here, right? Because it's very similar. So we can rewrite this as 5 times 4 times z squared times z. Okay? So we have a couple of perfect squares in here. We have the 4 and the z squared. That'll be helpful. So plus 3z times, now we can divide 80 by 5. That's what I was looking for last time, by 5. So that'll give us, 5 times 16z, the square root of that. This will go much smoother. So now if we split everything up here, we'll have the square root of 4 times the square root of z squared times the square root of 5z plus 3z times the square root of 16 times the square root of 5z. Yeah, this is going much smoother. Okay, so we have the 5z, the square root of 5z in common here. That's good. So now we have the square root of 4, which is just 2, times the square root of z squared, which is just z, times the square root of 5z, plus 3z times the square root of 16, which is 4, times the square root of 5z. So we have 2z times the square root of 5z. 3 times 4 is 12, so plus 12z times the square root of 5z. So we're almost done. This is going to give us 2z plus 12z times the square root of 5z, which is 14z times the square root of 5z. Okay, so yeah, these are pretty messy. So if you have any questions about any of these and you want some extra help, please feel free to shoot me an email or visit me during office hours or schedule an appointment with me, because these can get really nasty. So if you want some additional help on this, there's no shame in that at all. These can get pretty rough. So if you have any questions, as always, feel free to shoot me an email. Have a good one.